We have partial pressures. And so, partial pressures. We're going to have 1.5 grams of, what is this called? Yep, calcium carbonate. And we're going to say that calcium carbonate can decompose to form carbon dioxide and calcium oxide. And if we collect 65 milliliters of gas at this temperature, the total pressure of the gas collected over the water is 6.65 atmospheres. What is the vapor temperature of water at this temperature? So how should we start this problem?
Just run away to 5. If you don't have this Q2, the better way to find it is just
yeah, try to balance equation. So we're going to have CaCO3 is going to form CO2 plus CaO. And remember, this is a gas, and that is a solid. So, is it balanced? Yeah, it's balanced already. So if we know that 65 milliliters of gas is collected, what is our gas? Right, carbon dioxide, so that's our only choice. Calcium oxide is a solid, that's given to us in the problem. So the only gas that we could possibly collect is carbon dioxide. So is there a way that we could figure out moles of carbon dioxide? And
electric field.
How can we figure out? What's that?
Electric potential energy.
We could use the gas bottom in moles. Or what else can we do? That's a way to solve it. It's probably a little bit better way to solve it though. Yeah, we can turn this 1.5 grams into moles and then use the mole ratio to figure out how many moles of carbon dioxide are produced, right? So molar mass is given for a reason. We need to figure out how many moles of calcium carbonate we have. So, we're just going to take 1.5 grams divided by 100.06 grams, and that will give us our moles, which is going to be what? 0.015 moles of calcium carbonate, and we can convert that into moles of carbon dioxide. They're in a 1-to-1 ratio, so you don't actually have to change anything. You can just write that we have 0.015 moles of our carbon dioxide. That's within an electric potential. So now what should we do? Sure.
Yeah. So one thing that I use to remind myself
to get what? So we've figured out so far that this is how much carbon dioxide is going to be produced when we decompose 1.5 grams of calcium carbonate. We're going to make 0.015 moles of carbon dioxide. Yeah, we could. And what are we solving for?
If you take one mass.
Right? We're solving for T. So that's what we're looking for. So we can plug all this information into PV equals nRT. We know T is going to be 65 degrees Celsius, but do we use Celsius? No, we have to convert Celsius to Kelvin, right? So we need to convert 65 degrees Celsius into Kelvin. So that'll be 65 plus 273, which is going to be 338, right? So we'll say T times V is equal to N times R, 338 Kelvin. And R is still going to be the same value that it was before, and just to give it again, R is 0.08206 atmospheres times liters over mole Kelvin. And do we know N? right? We do know M, because M is going to be 0.015 moles. And do we know V? What's V? Yeah. Our volume is going to be the 65 milliliters, which, of course, we're going to want to convert into liters, because that's what we work with. We don't work with milliliters. So if you were to convert that, it's just going to be 0.065 liters. So now we know the values for everything except for P, which means we could solve for P. We just have to plug everything in. So if somebody wants to do that and tell us what we get for P, that would be helpful. So you said 6.40. And what are the units on that? ATM, right? It's pressure. So are we done with the problem? Yes or no?
So if A to G is like our E, R is still the same.
No, we're not done with the problem. We didn't ask what the pressure of the carbon dioxide was. We're asking what the pressure of the water is. So if we know the total pressure collected over water was 0.6 or 6.65 atmospheres, and that the pressure of the carbon dioxide was 6.4 atmospheres, what is the vapor pressure of water? Yeah, it's 0.25. All you have to do is say if this is the total, and that's part of it, then the other part would just be subtracting those to get the difference. And then that would be the water vapor, so that's the only other thing that would be contributing to the pressure. So we just do the 6.65 atmospheres minus 6.4 atmospheres, and we're going to end up with 0.25 atmospheres as our final answer. So the vapor pressure of water at 65 degrees Celsius is going to be 0.025 atmospheres. Now this problem is definitely probably the trickiest one that we've done so far. The other one is pretty simple. So does this make sense to everybody or not? Because I know at least when I was going through this class, this is the stuff I didn't understand in the class.